Okay, so now that we've looked at how the basic formulas for ionic compounds work, let's look now at how the naming rules work for ionic compounds. We know that ionic compounds are made of cations, the positively charged ions, and anions, the negatively charged ions. When we name ionic compounds, all we do is simply name the cation first and then the anion second. So let's look at how cations are named. Now, your book breaks up cations into type 1 metals and type 2 metals. This is not a standardized system of division. It's just something that your textbook has used to help clarify. By type 1 metal, they mean a metal with a non-changing charge. And if that is the type of metal it is, then the cation name has the same as the metal name. Now for cations with non-changing charges, take a look at page 136, table 5.3 of your text. Or take a look at the periodic table. Alkali metals always have +1, alkaline earth always have +2, aluminum 3, zinc 2, silver 1. These charges are always the same. They never ever change. All other metals on the periodic table have at least 2 charges available to them. So they are in a completely different group. But these are the cations with non-variable charges. Alkali metals, alkaline earth, aluminum, zinc, silver. +1, +2, +3, +2, +1. So let's look at some of these ions. Sodium, as an alkali metal, will always have a +1 charge. Calcium, always +2, and aluminum, +3. Now if we're looking at how to name them, what we're going to do is we're just going to use the metal name. So the name of this cation is sodium. The name of this cation is calcium. And the name of this cation is aluminum. Now this can lead to a little bit of confusion because sodium can be the name for elemental sodium or the ion. In our everyday life, this is the form of sodium that is much more common. And typically when we're talking about sodium as an element, we will specify and say elemental sodium. The same thing with calcium. Both sodium and calcium are very important ions in biological systems. And they're talked about a lot. Sodium in our food, calcium in our bones. So if we're talking about calcium as an element, we typically say elemental calcium. And that's how we distinguish between calcium as an ion and calcium as an element. Now let's look at what your book calls the type 2 metals. Type 2 metals are all the other metals that are not type 1. These are all metals that have changeable charges, more than one charge available to them. So like the type 1 metals, the name consists of the metal name, but we must also indicate the charge because it has several charges available to it. And for an example of this, look at table 5.4, page 136. Now the charge is written as a Roman numeral. So let's review our Roman numerals. This is 1, 2, 3, 4, 5, 6. This may be something that you want to keep handy. Now let's look at how these Roman numerals address the charge. Let's look at this ion. What would the name of this ion be? Well, we'll find this on the periodic table or look it up in the chart in your text, and we see that its name is titanium. Its charge is +4, and we indicate it with a Roman numeral 4. So the correct name of this ion would be titanium 4 with the 4 written as a Roman numeral. Now let's look here, and I've made the charge in red as well. What would we name this? It's not a type 1 metal. It's not alkali or alkaline earth, aluminum, zinc, or silver. So its charge is variable. So we name the name of the metal, and once we find the symbol on the periodic table, we see that this is iron. And then we must also indicate the charge. Since it has a +3 charge, the name is iron 3. Both parts are necessary for the complete name. Just like a unit is just as important as the number, this charge is just as important as this. Now let me go over a common misconception. When we are writing formulas, the 1 is not included. However, when we're naming an ion, we must always indicate its charge if it's a type 2 metal, whether it's 1 or not. So to correctly name this ion, we write out its name. And if you find a U on the periodic table, you will see that it is gold. You will also notice that gold, found right here, is not alkali, alkaline, or aluminum, zinc, or silver. Therefore, it has a variable charge. So we must write its charge down as part of its name. So the correct name for this cation is gold 1, with the charge written as a Roman numeral. The Roman numeral always refers to the charge. And then the last possibility for a cation is a polyatomic ion. And then we just name the polyatomic ion. And for a list of polyatomic ions, please see page 138, table 5.6. These are important vocab words for this class. If you can't memorize them, you definitely want to have them written down on your card. It's important to memorize the formula as well as the charge. Now let's look at naming the anions. After the cation in an ionic name comes the anion. And there are two main types of anions. Either one that's based on the periodic table, a non-metal, and here they are, -1, -2, -3, and then over here, rarely, -4. To name these anions, we have the stem of the non-metal name, and then it ends in "ide." So these are also called monoatomic anions because they're made of just one atom. So carbon with a -4 charge would be called carbide, silicon with a -4, silicide, nitrogen with a -3, nitride, phosphorus with -3, phosphide, oxygen -2, oxide, fluorine with -1, fluoride, etc. Notice we have the root of the name, and then they all end in "ide." So go ahead and pause the slide and see if you can correctly name each one of these cations and anions. I have 3 cations and 3 anions. Okay, this one here is calcium, and we don't need a charge on it because calcium always has a +2 charge. Here's calcium, alkaline earth, +2 charge. The name of this is silver, and silver is one of the ions, the cations. It's considered type 1, always has +1 charge, so we don't need the charge here. This is our anion, fluoride. Now notice that the anions have slightly different names than the element. If we were talking about the element fluorine, to a chemist, that would mean this. So the anion has a different name than the element. And here's nitride. And again, the anion is going to have a different name than the element. If we were talking about elemental nitrogen, this is the formula a chemist would use. This right here is arsenide, our root ending in "ide," and then here we have a cation. So it has the same name as the metal that makes it up. This is manganese, and manganese has a variable charge. It's not one of our type 1 metals, so we have to indicate its charge, which is 5, with a Roman numeral. Both of these components must be present for the name to be considered correct. If you've got all these right, give yourself a high five. The other type of anion name would be a polyatomic ion, and then that's just whatever its name is. And you can take a look at table 5.6 on page 138, which is basically right here. And if we see, most of the polyatomic ions are anions. there's one cation down here, ammonium. This is the only non-metal that we're going to look at in this class that could begin an ionic substance, because this is the only cation that doesn't have a metal. All other cations have metals. And these anions, it's important to memorize or recognize these formulas as well as know the charges. And if you can't memorize them, as I said, you want to have them handy on a card for a test or a quiz.